Hello students, let us try to discuss our discussion on the modern physics. So the topic of our discussion is modern physics. And in this modern physics, we are going to discuss the first chapter that is mentioned in your syllabus as the number 20, which is electron. And in this electron, the first topic is your Millikan's oil drop experiment, which is used to find the charge on the oil drop. This is the first experiment, first topic. And second is your motion of charge particle in an electric field and magnetic field. Motion of charge particle like electron or proton or something like this motion of charge particle in electric field or magnetic field. Electric field, basically you have read in class 11th as E vector, and magnetic field you will be reading as B vector. Both are vector quantities. And third, that will be the end of this exercise. Thomson's experiment for finding a specific charge. E by m is called a specific charge by mass ratio of electron. This is the third experiment by which, this is the third portion by which this chapter will end. So this is the basically plan of modern physics first exercise, that is the electron. Now in this exercise, in order to understand properly the Millikan's oil drop experiment together with the Thomson's experiment for finding the specific charge of electron, you should understand that this is the first topic that we will be making the discussion in order to understand this properly and in order to understand this properly. In order to understand both properly, what I mean to say that we will be first discussing the motion of charge particle in electric field, then we will discuss the motion of charge particle in magnetic field, and then we will start our discussion Millikan's oil drop experiment together with the Thomson's experiment for finding a specific charge of electron E by m. So let us try to discuss the charge particle. The basic charge particle, as you already know, is the electron, proton and neutron. Electron is negatively charged, proton is positively charged, and neutron is neutral. What does it mean? It means simply that if we want to see the effect of electric field on proton, electron and neutron, then those effects will be different. So first we should understand the electric field. That electric field you have already read in class 11th as this matter, that electric field is force per unit test charge. This is the electric field definition. It is basically your definition. When this is the definition of electric field, then certainly we can understand its unit will be Newton per coulomb or volt per meter. This is the unit of electric field. And electric field, you already know, is a vector quantity. Electric field is a vector quantity. The direction of electric field is the direction of movement of positive charge or opposite to the direction of movement of negative charge. So what I mean to say to you people, that positive charge moves in the direction of electric field, whereas the negative charge moves opposite to the direction of electric field. There is a concept of uniform electric field. What is that uniform electric field? Uniform electric field is represented by equispaced parallel lines. Equispaced parallel lines represent uniform electric field. What does it mean? It means that electric field is constant in magnitude and direction everywhere throughout the region. So we can say, if we take a positive charge Q naught, then the force is this is the force. F is equals to Q naught E is the force on the electric charge in the uniform electric field E, and the direction of this force is along the direction of electric field, that is in this direction. Whereas if we take the negative charge is minus Q naught, and in this case the direction of electric field is opposite to the direction of force is opposite to the electric field, that is, this is the direction of force on the negative charge. So we can understand, if a neutron we keep here in the uniform electric field, there will be no force on the neutron, as neutron is the neutral particle. So what we can finally understand, that charge on electron is opposite to the direction of electric field, charge on proton is in the direction of electric field, together with the charge on neutron, together with the force on neutron is not there, as it is a neutral particle. Now let us try to discuss the motion of electron in an electric field, that is negatively charged particle. Electron is in uniform electric field and it is being projected. So if the direction of projection of electron is in the direction of electric field or opposite to the direction of electric field, that is parallel or anti-parallel, then we can observe very carefully that the path of electron will be a straight line. It will be a straight line, parallel or anti-parallel to the direction of electric field. But if the electron is projected perpendicular to the direction of uniform electric field, then what would be the path that we would like to try to discuss. So first of all, we have to generate the uniform electric field. And in order to generate the uniform electric field, I am taking a parallel plate capacitor. See, here the plates of the parallel plate capacitor are there. One plate is connected to positive terminal of the battery, so it acquires positive charge, and the other plate is connected to the negative terminal of the battery, so it ultimately acquires the negative charge, and there is a uniform electric field that exists between the plates. Here the electron is being projected. Suppose E is the charge on the electron and ME is the mass of the electron. ME is the mass of electron and E is the charge of electron, and the initial velocity of projection along x-axis is V0. As the force will act on the electron, so electron will take the direction this parabolic path. This is the parabolic path that the electron is taking here inside the electric field. If we consider x as the length of the region in which uniform electric field exists, then this vertical displacement we can take as y. Vertical displacement we can take as y. So there are two parameters that we are supposed to find in this situation. One is the vertical displacement y, and the other is the direction theta in which the net velocity of electron makes with the horizontal direction. So this type of motion we can study by dividing the motion. This is a two-dimensional motion. Both in x-axis the motion is there, both in y-axis the motion is there. Y-axis vertical motion is there. This motion is due to the force, and in this direction there is no force that is acting. So this is uniform and this is accelerated. Now in order to find this value, what I would like to do, I would like to divide the motion into x direction and y direction. So motion in x along x-axis. Motion along x direction. In x direction, the initial velocity is V0 of the electron. Force in x direction is 0. No force is acting. So acceleration in x direction is also 0. If we want to calculate the time that it has taken to cover the x distance, then that time will be given by t is equals to x by V0. This is the time in which the particle, the electron, basically covers the horizontal distance as x and vertical distance as y. So in covering the vertical distance y, it takes the time t, and in covering the horizontal distance x, it takes the time t. So this is the value of t that we have calculated. Now if we want to find the motion along y-axis, then let us try to understand. Uy, initial velocity in y-axis is 0. Fy is equals to EE. Charge into electric field. Acceleration in y direction. AY. EE by ME. This is AY. If we want to find the vertical displacement y by using the formula S is equals to ut plus half at square. In y direction we are talking, so we are talking about Sy is equals to uyt plus half ayt square. Ay is acceleration is y direction, Sy is vertical displacement along y direction, and uy is initial velocity along y direction. So if we want to find this thing, then you see initial velocity in y direction is 0. So first term is 0. Vertical displacement along y direction is y according to the diagram. So it is your y. And ultimately we are getting a relation So y is proportional to x square. Y is proportional to x square. This simply means that this is the path is parabolic. So this relation proves that trajectory of electron inside uniform electric field is parabolic in nature. The trajectory of electron inside the uniform electric field is parabolic in nature. In order to simply remember the parabola, you should remember in this way. This shape is parabola, or this shape that you are taking, this is also parabola. So this type of shape, here also we are getting the same similar shape. And you have read in projectile motion in the 11th class, that also tells about the parabolic nature. So the motion of electric field, if the direction of electric field is perpendicular to the direction of velocity, here you see the direction is 90 degree. Between initial velocity and electric field, the direction is 90 degree. So if the electron is projected horizontally to a vertical electric field, then the result is that it is parabolic in nature inside the electric field. Now the second problem is there. This thing you should understand, that here this constitutes your 3 marks question. In the NEB examination. In the NEB examination, this will be asked as 3-mark question. And for finding the theta, that will be the another question for 2 marks. So in order to find theta, what I will tell you, Vy is equals to Uy plus Ayt. This is giving you the expression for Vy. We have found Vy, we have found Vx. So resultant is your this V, and this angle is theta. So if we want to find theta, tan theta is equals to Vy by Vx. Vy we have already calculated. Vy we have already calculated, E by Mex by V naught by V naught. So we are getting tan theta. This is the expression for tan theta, which will give you the angle inside the electric field. Inside the electric field, don't say, when the electron emerges out of the electric field. So in this way, what we have understood that the motion of charge particle inside the electric field, especially if we talk about the proton, the proton will go towards the negative side of this plate, parallel plate capacitor. So proton will go in this direction, electron will go in this direction, and neutron, which is a chargeless particle, that will go straight without being affected by the electric field. So finally we have concluded to this conclusion. Finally we are coming to this conclusion that if the charge particle is projected in the uniform electric field, we can easily find the direction of electric field, the direction of velocity after emerging out of the electric field of an electron, together with its nature of path, that is the parabola equation we have got, that this is the displacement, vertical displacement y, and finally we come to the conclusion that the path is parabolic in nature with angle of emergence tan theta is equals to E by m. So I hope that you have understood this matter in a very careful way, and there is no shortcut, that you already know. There is no shortcut, there is no substitute of hard labor. So if you will concentrate on this matter and practice enough, give time proper to it, you can understand it in a better way. There is no question of not understanding this matter, as it is very simple, provided you have the background of electric field. Now we will try to discuss the effect of motion of charge particle in magnetic field also. But before that, we will try in the next session, I will discuss you few questions based on this concept. Thank you. Have a nice day. Goodbye.